Hi guys, this is Acid Base 101 and this is part 3B, and what we're doing here are pH example calculations. And I led with just a couple of reminders. Well, this is more of a new piece of information, but this last part here is a reminder. So we want to start off with, for any strong acid HX, the concentration of the acid itself is equal to the concentration of the hydronium ion, because every H plus on this guy is ionizable. So, and then I just kind of went on to clarify that that's meaning that there's an H plus that can be transferred or donated. Okay, and then this was a reminder right here that you can find pH or POH, if you know either one, by using the equation pH plus POH equals 14. And then the math that you do to get from pH is 10 to the negative pH, and that gives you H3O plus. If you want to go back, you negative log that concentration. And if you want to go from the hydroxide concentration to POH, then you negative log the OH concentration. And then the same, likewise, opposite, to go to the hydroxide concentration from POH, it's 10 to the negative POH. And if you want any of the math details behind that, I can certainly give those to you. So in our example number 1, we are asked to calculate the pH of a solution that is 0.00858 molar in HNO3, and then to calculate the POH also. So we can recognize first that HNO3 is an example of a strong acid, and that would be our H here, and then our X would be nitrate. And so we can say the concentration of the HNO3 is equal to the concentration of the hydronium. So that's going to be equal to 0.00858 molar. And all we have to do to find pH then is just negative log this number, because pH is the negative log of the H3O plus concentration. So we're going to go negative log of 0.00858. And we get pH equals 2.1. And then we can calculate the POH very easily. That 14 minus the pH is going to be equal to the POH. A little bit of baby algebra there assumed. 14 minus 2.1 is going to give us, what would that be, 11.9 for the POH. Okay, and this solution then, of course, with the pH below 7 is going to be acidic. All right, so that's our first example. Second example, calculate the pH and the POH of a solution that is 1.2 times 10 to the negative 4th molar in OH minus. And so we're going to recognize here that we have the hydroxide concentration, and there's a couple different ways you can go about this. I always go straight to the POH or the pH first. So if we negative log the concentration of the hydroxide ion, then we'd have negative log of 1.2 times 10 to the minus 4. So negative log 1.2, so negative 4. And we get that the POH, that's what this expression is 3.9. And then we can do 14 minus the POH to get to the pH. So 14 minus 3.9 would be 10.1 for the pH. And of course this then tells us that it's a basic solution because it has a pH above 7. Gosh, I hope I didn't block that whole thing out with my calculator. Okay, and our last example, we have a solution of HCl, excuse me, is made by dissolving 5 grams of HCl in 3.50 liters of solution. and I asked you to calculate the pH and pOH of this solution. So we want to recognize here that we're not given molarities. We're given grams and we're given liters. In order to get to molarity, you got to remember that you need moles per liter of solution. Can you see that? You guys have young eyes. You can probably see that green. Okay, but I can't, so I'm going to change pens. So the first thing we want to do is convert to moles. And so we're going to go 5 grams of HCl and just convert that to moles. And this guy has a molar mass of 36.461. We'll invert that and multiply by 5. Okay, so we get 0.137 moles of HCl, and we know it's dissolved in a solution volume of 3.50 liters. So we'll divide this by 3.50, and we get 0.0392 molar. And so we have 0.0392 molar, and that's in HCl, which is a strong acid, and we'll define strong versus weak in our next set of notes. So that's going to be equal to the concentration of the H3O+. So if this is our HX. Okay, so if we know the H3O+ concentration, we'll negative log that. And we get 1.41, and oops, sorry. I should have said I negative log this. And that's 1.41, so that's our pH. And then if we go 14 minus that number, we get 12.59 for our pOH. Okay, so very acidic solution. All right, those are your 3 examples. I hope you guys are doing good, and yeah, stay safe, and hopefully I'll see some of you guys tomorrow on our office hours. All right, take care.